4.7 Solar Radiation in the Earth's Seasons. Here's a comic from XKCD with a little map showing where you should live if you like hot versus cold, etc. Just a silly little thing. The factors that affect the amount of solar energy at the surface of the Earth, it first directly correlates with primary productivity, so the amount of energy that plants are capable of making. 2, you have rotations, how fast the Earth turns on its axis. Revolution, how quickly the Earth moves around the Sun. The Earth's tilt, which is 23.5 degrees, so that axis on which it rotates is tilted. And general atmospheric conditions. If it's cloudy, you're going to have less solar radiation reaching the Earth's surface. The causes of the seasons. Most importantly, it is not caused by the Earth's distance from the Sun. That is a fool's supposition. You're smarter than that. The Earth's seasons are caused by the tilt of the axis, not the distance from the Sun. The tilt of the axis influences how long the Sun is up, and the angle at which the Sun's energy strikes the Earth. The more directly it strikes, the closer to 90 degrees perpendicular, the more intense the solar radiation, the less diffuse it is, the higher the temperatures. Not distance from the Sun. Here's an example of that. Here, this is going to be winter in the northern hemisphere. The sun's rays are hitting it, and it's spreading out over a larger area of land than in summer, when the sun hits the land, it's hitting more directly. It's not spreading out over a wider surface area. We had a fantastic Bill Nye video. I'll link that in the description. Now we have the difference between weather and climate. Weather is the short-term atmospheric conditions at a given point or time. It typically doesn't last more than a couple of days at most. Some examples of weather: temperature, pressure, humidity, precipitation, amount of sunshine, cloud cover, wind direction, wind speed. These are short-term, day-to-day conditions. Compared to climate, which is the overall long-term average atmospheric or weather conditions. You can predict that in the American Southwest, it's going to be hot and it's going to be dry. Now, the day-to-day weather, there might be rain. Some days might be cloudy. Some days may be rainy. But the climate, the overall long-term average atmospheric conditions are hot and dry. Mark Twain, aka Samuel Clemens, had a nice little phrasing that I enjoyed. Climate is what you expect, weather is what you get. So climate is what you could average, like if you were a gambling man, you could bet would happen, and then weather is the actual outcome. That's what is going to happen. 4.8 and 4.9 are both short, so we're going to combine these into one video. So, Earth's geography and climate. Here we have a graph showing the increasing incidence of severity of drought in California from 2000 to 2014. This trend has only continued and gotten worse since then. As you can see, in 2000, there were some dry areas, but parts of the state were okay. By 2014, every part of the state is in some form of drought. Here we have the Intertropical Convergence Zone, the ITCZ for short. This is the zone of the Earth near the equator, where the two Hadley cells in the northern and southern hemisphere blow towards. They carry that moisture-heavy air towards it. It gets to the equator, it gets hot, it starts to rise. That moisture falls out as precipitation. The Intertropical Convergence Zone. You have high temperatures, and it's very wet. This is just to show you that the Earth's climates roughly follow latitudinal gradient. There are some exceptions. For instance, right here, there's a pretty significant disparity in the latitudes. That's influenced by things like geography, topography, angle of sunlight, proximity to large bodies of water, etc. So, in addition to latitude, what impacts the global climate patterns? Air circulation, ocean currents, the angles of the sun's rays. We've talked about that before with seasons. And then here we have a point that's worth being specific about. Heat and precipitation on Earth are not distributed evenly. Different parts of the Earth are heated more, different parts are heated less. Some parts receive more precipitation, some parts receive less, etc. Okay, proximity to water and mountain ranges can have a significant impact on your climates. We have San Francisco, Wichita, and Virginia Beach. They're all at roughly the same latitude, but they have very different climates. If we look at the numbers, in San Francisco, their low average temperature in January is 46 Fahrenheit, and their high in July is 71 Fahrenheit. As opposed to Wichita, which has a colder cold and a higher hot. And then Virginia Beach is kind of in between the two. San Francisco is kept very mild because of those ocean winds coming in from the Pacific Ocean. It keeps the air and water around San Francisco at a very moderate temperature. It has a high specific heat, so it doesn't cool off or heat up very quickly at all. So it resists those temperature changes. You end up with a more stable temperature. You don't have those wide extremes. As opposed to, like in Kansas, there is no water near it, so the air changes temperature relatively quickly and easily, so you have a bigger disparity in your highs and lows. And Virginia Beach is in between because, yes, it is close to water, but prevailing winds are blowing from west to east at this latitude. So you're getting some of that insulating factor from being close to water, but it's not as pronounced as it is in San Francisco. And then mountain ranges can introduce this rain shadow effect, where you have moisture-heavy wind coming in from over oceans, blowing inland. As the air hits the mountain, it increases in altitude, which is going to decrease its pressure. If you've decreased pressure, you're also decreasing temperature through adiabatic cooling. If your air is cooler, it now cannot hold as much solute. That's basic solution chemistry. So the moisture in it, which in this case is the solute, is going to fall out of solution as rain or snow. By the time the air gets to the top of the mountain and starts moving back down, it starts sinking, there's no moisture left in it. So geographically, opposite sides of a mountain can be very close, but they can have very different climates. On the rainy side, the wind side, where you're getting that ocean water, it's going to be more moderate. The hots are not as hot, the colds are not as cold. Same latitude, you would expect the same amount of heating from the sun, but you have a wider temperature range because you don't have that precipitation functioning as an insulator anymore.